formula on your study sheet, okay? And I'll tell you why. Because the one they have on the formula sheet is not good. It's not good, okay? I'll give you my version of it, and that one will help you big time, okay? Expected value. It is an application of probability that involves the likelihood of gain or loss, okay? It is stated, your final answer is stated as a dollar amount. Make sure you get that right, because a lot of students forget that it's a dollar amount. Expected value is relevant in business, insurance, and many situations in your daily life, okay? The concept of expected value can be used to determine, here's the main, I'm going to use a different color for this one. It is used to determine whether or not to participate in games of chance. That is the main reason we calculate the expected value. The expected value is only accurate in the long run. I think because you're basically making a prediction, okay? After playing a game many times, right? So you need a large sample size for this to actually work itself out and actually be observable. So here's the formula, and I know it's weird, but make sure you have this on your study sheet. I will explain it though, because you need to make sure you understand what's happening here. By the way, under expected value, make sure you put a dollar sign so you know that your answer is going to be as a dollar sign. And watch what it says. Okay, when you go play games at a fair, have you ever been at a fair like the Red River X or anything like that? You play those games, right? There's usually more than one way to win money, right? Usually there's like the first prize, second prize, third prize. So this formula accounts for that there's more than one way of winning the prize, okay? So there's a probability of winning the first prize. You have to take the money or the value of the prize minus the cost it took to actually participate in it. So let's say the ticket is $2 for the game. If you win $5, folks, make sure you look up here, right? If you win $5 but you paid $2, you've really only gained $3. So that's what you need to make sure you take into account. I call this the gain, okay? This part right here is gain 1. So your wallet technically would only be bigger by $3 because you spent $2 to win 5, okay? Then we go plus. Probability of winning the second prize. There's the prize minus the cost. So this would be gain number 2. Okay? And then watch this. I'm going to use a different color just for that end part, because this one will always be there. Always. Minus probability of losing times the cost. Always subtract this, okay? So we figure out winning, and then at the end we'll go minus probability of losing. So I will put down expected value here one more time. If a province ever says, calculate the expected value, boom, you're going to this formula immediately. Okay, question, could it be that there's only one prize to be won, period? But it could be that there's only one, just so you know. It could be that you play some kind of weird game and there's no second prize to be won, there's no third prize to be won, that's okay. Like the bubble gum machines, you know those ones? If you get the black one, you get, what do you get? I don't know. I used to try to get it, but you never got it, right? But that is usually just a one win, I think. Or is it different colors? I'm not going to go into the details of that because I might get it wrong. But anyways, you got to just remember there could only be one prize, in which case this here is just gone, okay? There would just be prize of winning that one prize, and then for sure you have to subtract the probability of losing. Follow my train of thought here. If there's an 80% chance of winning, what would be the probability of losing? 20%, okay? So sometimes they don't tell you what the probability of losing is. You just have to figure it out. When you compute this and you get an answer, okay, you may be asked if you should or should not be playing the game. Okay, so here is the look at the sign, right, to determine what it tells you. If it is positive, so you figure out your expected value. By the way, let's go money again. It's gonna be a money amount. If this number is positive, okay, that means that there's a gain expected for the player in the long run. This is good for the player, but bad for the host. So if you were the casino, you'd say a positive answer is not good for the host. So this is a bit of a tricky one. I'm just going to stick with good for the player for now. If it's a 0, okay, if you get a 0, then it's considered a fair game. You break even. Your choice to play. So it doesn't really matter. You will win some, you'll lose some, but at the end of the day, you're not going to gain or lose, so you're good. That's up to you if you want to play. Negative, okay, if the answer is negative, loss expected for the player, bad for the player. However, good for the host, right? So casino, if you do the math on that machine and you get a negative answer, as the host, as the owner of the machine, you're like, right on, I'm going to be making money because the people playing are going to lose, right? So they threw that curveball at us last exam, and that's why I added that here. Okay, a lot of students said, oh, a negative answer, it's good, but they were asking from the host's perspective, what would that be? And the answer is, it's bad if it's positive, good if it's negative, okay? Let me just give you some examples. You might get examples like this where expected value may literally be 0.03 or 1.29. These are all positive answers. It would still be good to play. Listen carefully. Some students say, oh, it's only 3 cents. It's not a good idea to play because it's so small. Shouldn't bother. For us, since it's positive, we still say it's go ahead and play. Because if you play this 1,000,000 times, you'll still be rich, right? Example for negative answers. You know what? I'm just going to use the exact same numbers, but I'm going to say that if you get a negative, right, or a negative 1.29, these are all bad, bad for the player. Do not play. The value calculated for the EV is the average amount you're expected to gain or lose per game/bid. It is only true in the long run. It will not work if you only play a couple of times. Okay. So let's go and practice actually calculating it, because it's usually 3 marks for one of these questions. So there's a lot at stake here. So you just need to make sure how to work it. Okay. So let's go to page 70 and try this out. Make sure you put any distractions away. Don't think of the weekend right now. Just follow me on this one example, and hopefully it will make sense to you. Let's read it first. A game at a summer fair consists of drawing marbles from a bag. The bag contains 10 red, 30 yellow, 60 white. Okay? If you draw a red marble, you win $25. If you draw yellow, you win 7. If you draw white, you get nothing. Okay, you basically you lose. It costs $3 to play the game. Calculate or determine the expected value for each game. Here it is. That is the key word there. It's asking for expected value. Right? What is the expected value? So you should go to your study sheet and look up that formula. Okay, let's say worst case scenario, you forget about it. Here is the expected value formula on the green sheet. It is there to a certain degree, but I do not like it. First of all, it just has win, lose, and it doesn't show you the subtracting part. Watch, they want to have on mine. I tell you to take the prize and subtract the cost. That is the most common error that students forget to do that. Okay, so I would say worst case scenario, it's there, but I would use the one I gave you. This is prize number 1 in no particular order, okay? Prize number 2, and so there's 2 prizes to be won. So let's do our calculating here. Expected value is probability of winning the first prize. Okay, that is going to be a fraction to be continued, okay? Times the prize 1 minus cost plus probability of winning the second prize, and there's the prize there minus the cost. You always subtract the cost from that win. And then last but not least, minus probability of losing times the cost. I'm going to highlight cost with any color of your choice. But the cost to play the game, the cost to enter this bid, it could be a bid, it could be anything. From a business perspective, it could be a bid. You always subtract it. Every single time, you should somewhere see the cost, even on the last one. And you're like, Mr. Dixon, you're not subtracting here. Technically, you are, right? That negative up front here is subtracting. So that's where it's at. So let's fill this in with numbers. Expected value. What's the probability of winning the first prize? It's when you draw a red marble, correct? How many marbles are there in total? Let's figure that out. 60, 30, and 10, that's 100 marbles. So let's write that down. You need to have a total to come up with a probability. So that's kind of nice that it's 100. So we know this is 100, and 10 marbles are red. Just put it like this, in brackets. I like it in brackets like that. Then you're going to go, the prize would be $25, but remember, you've paid $3 to play. So you go like that. Don't rush these ones. You add the probability of winning a second prize as well. So you go drawing a yellow, right? And there are 30 yellow marbles. So you're going to go 30 over 100. That's the probability of winning the second prize. The money is $7, right? The prize is 7. And remember, we take away the 3, because even if we were to win it, we would really only gain $4. Last but not least, I'm going to use a different color. I'm going to try to make this clear. Minus what's the probability of losing here? There's several ways to get it. It says that if you get a white one, you get nothing, which is 60 out of 100, correct? But you also know that you've already used up 10 and 30, right? So this is 10%, 30%. So this has to be 60% anyways. Whether they tell you or not, there's a way to figure this one out. And the cost is just $3, so that's where this is different. You just plug in the 3 there, and that's it. I would clean it up one more time. And just the subtraction. So that's 22. 30 over 100. 7 minus 3 is 4. And the last one is already cleaned up. So grab your calculator. So 10 divided by 100, hit equals. Then I multiply that by 22. That's 2.2. Okay, plus 30 divided by 100. Remember, these aren't always going to be nice numbers out of 100. It could be anything. It could be 3 over 19. It depends on the situation. Times 4, that's 1.2. So we go plus 1.2 minus. The probability of losing is usually the highest, right? That's usually how games work. 60 divided by 100 times 3, that's 1.8. Okay, so 1.8. And at this point, we are almost ready. And just remember, this is a dollar amount. So here we are, 2.2 plus 1.2 minus 1.8. And you get positive, right? I don't have a negative there, so it's 1.6. This is going to be giving you a half mark deduction as is. It's dollars, so you need to make sure you add the, and it's positive. Note, answer is positive. And you gotta make sure that note is there. So you want to make sure you add your units, and you want to make sure you add that, right, so you don't get a rounding error. But this would be your final answer, which is, for the player, that's a good one, right? You expect it to win in the long run. So yes, be careful with your substitutions, like how you plug in your numbers, and then take your time to clean it up. The biggest temptation is to just type it in all in one shot and then you get it wrong. It'd be too bad. You've done so much work already. Don't rush. Okay. So here, should you play this game? Justify referring to answer A. Yes. Since the expected value is positive, a gain is expected. Okay. Note, this is not good for the host, as money will be lost. I'm just adding this because a lot of students got, we complained. We were like, that's, because a lot of students got that wrong, because they were like, oh yeah, it's positive. Of course it's good for the host. And it's like, actually for the host it's not, just for the player. Okay? If you were to play the game 125 times, how much would you expect to win or lose? So we determined there's a win here. So you would go 125 times the 160. $1.60 that you're supposed to. So that would be $200. Oh yeah, here I added it just last minute. Should the fair offer this game? No. Since a positive, it's very important that you talk about whether it's positive or negative. since a positive EV means that players will win, but the fair will lose. Okay? To summarize it one more time. Okay, I'm going to ask you to practice this. That's the only way to learn. You got to practice. And I will post the key and I'll walk around. I'll probably do one more on Tuesday next week. But you've got the rest of today's class to practice. Okay? Thank you, guys. So pages, what, 71 to, let's say 71 to 73. And I will post a key probably to more than just those pages, but that's a pretty good start.